If you're thinking about printing ABS or ASA on your 3D printer, you may find our Slurry brush as a valuable tool in your 3D printing toolkit. Don't adjust your internet feed. Printable Science presents a 3D printed filament slurry brush.
This video has been made possible by the generosity of our patrons and viewers like you.
The advantages of PLA are numerous. It's cheap, relatively dimensionally stable, and given that it doesn't even require a heated bed, contributes to making it just about the easiest filament to print with. But PLA does have its drawbacks. It breaks down in ultraviolet light, and that over time will cause the plastic to become more brittle, and if the object is under any kind of stress at all, it could cause part failure. Also, PLA doesn't handle heat very well, and it'll begin to deform and droop in surprisingly low temperatures. For those reasons, 3D printer owners often try on other filaments that offer improved characteristics of UV shielding and higher temperature limits in order to print off parts that can function well in more extreme environments. However, once you stray from PLA, the choice of 3D printer filament becomes a dark and dangerous place, and some filaments seem almost impossible to print. They may require high nozzle temperatures beyond the capacity of your printer, or they may be difficult to stick to the build plate. A popular approach to improving build plate adhesion is to make a slurry of your dissolved filament so that you can pour it onto the build plate, let the solvent evaporate, and leave you with a thin coating of your filament already adhered to the build plate that will naturally adhere to the base first layer you'll be putting down. As most of you probably know, acetone is a solvent for ABS. In fact, it enjoys a lot of use in the smoothing of ABS prints. Now, what you might not know is that acetone is also a solvent for ASA. ASA is starting to gain more attention because it's UV resistant and relatively high temperature, so it's perfectly suited to outdoor applications. Making a slurry is pretty straightforward. You just toss in some pieces of your ABS or ASA, but not in the same pot. You need to make separate slurries for each type of filament you use, and you probably want to have them separated by color as well. That's because the slurry you evaporate on the build plate will bond almost perfectly with your printed part, and if it's of a different color, then you'll have a noticeable difference in the finished print. You can, of course, just snip pieces from your filament roll, but I usually use pieces of discarded prototypes or failed prints. Now, I'm making a gray ASA slurry to match my current project needs, and I've tossed in enough filament into the jar, so now I just need to add acetone, shake it up a bit, and then give it some time to dissolve the plastic. I'll come back when that's done. Okay, we're back. While the camera was off, I did shake the container a few times to help with the melting, and now we're good to go. But before I pour this on the build plate, let me show you this project's printed part. It's what I call a slurry brush. Its purpose is to let you move the slurry around the build plate so you can spread it out and get a nice even coating without getting it all over your fingers or clothes or work surface. You can see it's just a hexagonal cylinder with a whole bunch of short little fingers on the end, which may seem impossible for a 3D printer to actually print, but we take the design principle of the famous hairy lion and print the brush sideways with an end plate so that we can form the fingers by short little bridges from the top of the brush to the end plate. When the brush has finished printing, we can use a scraper and knock off the end plate, leaving us with our fingers all ready to do their work. So now we pour the slurry onto the build plate and use our brush to spread it around, and once that's done, we just allow the solvent to dry and evaporate off our build plate, and now it's ready for use. As mentioned, our slurry brush was printed in PLA with a 0.4 millimeter nozzle diameter, 2 perimeters, 3 bottom layers, 5 top layers, a Z height of 0.2 millimeters, and a 20% infill. You can check out the description for the link to download the STL file for this project. So there you have it, a 3D printed slurry brush that will gain the admiration of your friends invoke the suspicion of your enemies, and allow you to summon lightning to the location of your choosing. Thanks for watching, and I hope the Slurry brush comes in handy as you move beyond PLA for your 3D printing projects. If you want to keep in touch and keep an eye on what's going on here, then you know what you have to do. As always, we also invite you to visit our website at printablescience.com, where all the science that fits, we print.